Hello everyone. Today we are going to continue with the current electricity. It's a part 3 video. Okay, it is a revision for NEET exam also. Okay, so today we are going to do with current electricity continuation where we left yesterday. Okay, so we are doing all the concepts from current electricity. So I'll be start with the concept. Okay, so yesterday we did basic concepts. Today we will be doing with the little difficult concept we are going to move. Okay, yeah, we'll start the class. Yeah, today we are going to see the concept vector form of Ohm's law, a relation between current and drift velocity, okay, and color code, then factor, so how the temperature is affecting the resistance, okay. These are the three main concepts today we are going to discuss. I'll repeat what are the concepts today we are going to see. The first one we are going to discuss about how the vector form of Ohm's law and relation between the current and drift velocity, okay. The next concept we are going to learn it is how the temperature is going to affect the resistance. Okay, then we are going to discuss about color code. These are the three main concepts today we are going to discuss. Okay, the first we will be start with one by one. Yeah, first we will do relation between current and drift velocity. Current and drift velocity. Okay, first you need to know what is drift velocity. The average velocity between two successive collision. Okay, the average velocity between two successive collision. Okay, so before going to the drift velocity, you need to know three concepts. Okay, what are the three concepts? No, first one is the mean free path. Mean free path. Second one is relaxation time. Okay, so second one is relaxation time. Relaxation time. Third one is the drift velocity. So these are the three concepts you need to know. Then we'll go with the equations. Okay. First one, what is mean free path? So mean free path. So we have conductor like that. Okay, we have conductor like that. When we applied the battery, okay, when we applied the battery, so it will be applied like this. That's going to be the potential difference when I apply. Okay, it is defect of electron. It is excess of electron. So electron will be moved from negative to positive. So when the electron is moving from this end to this end, when the electron is moving from negative to positive, current is moving positive to negative, but the electron can be moved from it is negative to positive. Okay, so when the electron is moving here, a lot of proton is there, that will be offer the resistance. Okay, so it's going to collide with all the protons. Okay, when it's the electron is moving, it's going to collide with all the proton. Okay, so the average velocity between two successive collision we are taken as a drift velocity. Okay, the average distance, average velocity between two successive collision. Okay, not only this is the distance. It is this path we can call mean free path. The timing we can call relaxation time. That velocity we can call drift velocity. Okay, average distance between two successive collision. Not only one or two places, it's all the place. Average distance between average distance between two successive collision is called mean free path. Okay. Average time taken between two successive collision is called relaxation time. Okay. Average velocity between two successive collisions we can call drift velocity. Okay, this is a concept we have to know. Okay. Now I am going to do the relation between current and drift velocity. Okay. Current is equal to charge per unit time. It's very simple. Okay. See how I am going to relate with drift velocity. Okay. So charge is equal to n times of electron. This usually will be taken. Okay. But here n is not n. Okay. It is going to be number of electron per unit volume. Okay. When we are taken as a number of electron per unit volume of the conductor, the equation is not going to balance. Okay. Because a denominator will get as a volume. That we should manage. Okay. So first I am finding the Q. Q is equal to number of electron per unit volume. That's going to be divided by volume, means this is going to be into volume also I should make it. Why I am doing multiplication of volume? Because number of electron per unit volume is not going to give us the charge of electron. Okay, will give the unit will be become as a wrong. Okay, so if you are multiplying with volume, then only this will get balanced. Okay, N V E, like that we can take it. Okay, see how I am going to do next step. So volume I can take it as area into length into electron. You can take it like this. Okay, then time period I am going to divide here denominator time period into time period. Okay, volume I am writing length into height or area into height. Okay, so volume actually length into breadth into height. No, like that area into length, it's going to give us a volume of the conductor. Okay, now length by time. Okay, the length of the conductor and the time taken to reach the electron from one end to another end, we can take it as a drift velocity. Okay, length by time we can take it as a drift velocity. So Q is equal to N A V D E T. Why I got multiplication of T? Because denominator and numerator directly I added with the time. Okay, time period. Okay, then only length by time will get as a velocity. Okay, one more T also will be there. Okay, now I am taken what is the current. Okay, we found only the charge, not a current. Okay, charge is equal to, sorry, current is equal to charge per unit time. Charge per unit time. What is charge now? N A V D. It's going to be drift velocity. E is the charge of the electron. Time period divided by time period. Time get cancelled. Okay, time get cancelled. So now we'll get, it is the relation between current and drift velocity. It's a very important relation between current and drift velocity. Okay, now current is equal to N is the number of electron present per unit volume. Okay, and A is the area of cross section of the conductor. L is the length of the conductor. Vd is the drift velocity, average velocity between two successive collisions. We can take it as a drift velocity. Okay, E is the charge of electron. This what we will get as the relation between current and drift velocity. Okay, now we are going to discuss what is current density. Okay, so current density. So current density, it's the symbol we can take it as a J. Okay, so current density is equal to current per unit area. Okay, current flowing per unit area, we can take it as a current density. Already I know current is going to be N A V D E divided by A get cancelled. So current density will get N V D E. This is the current density finally I'll get. Okay, now we learned what is current density. Okay, this is a relation between current and drift velocity. This is a relation of current density. Okay, next we are going to do with the vector form of Ohm's law. It's very long calculation. Okay, we are going to do it. Yeah, no clarity. I think now we will get good clarity. Okay. Okay, now we are going to learn vector form of Ohm's law. Okay, see how I am going to do with the vector form of Ohm's law. So, it is called vector form of Ohm's law. It's very important equation. From this, I am going to connect with the resistance and Ohm's law. Okay, resistivity and vector form of Ohm's law, current density, drift velocity, everything I am going to relate with this equation. Okay, see how I am going to do it. Okay, I will be starting with the very basics. Okay, so here we have the conductor. Already I told you mean free path, relaxation time and drift velocity. Okay, what is mean free path? Average distance between two successive collisions. Okay, what is relaxation time? Average time gap between two successive collision. What is drift velocity? Average velocity between two successive collision. Okay, this three definition already we know. Okay, so I am taken the initially the electron will be moved in a random direction. It will be moved here and there. It's not going to get any direction, okay, because it will be not specified. Okay, when we apply the potential difference, when we apply the battery, okay, when we apply the battery, it will get the direction. Okay, so all the electron will get direction. Okay, so initial velocity we can take it as initial average velocity, we can take it as a 0 because it's not going to give any specific direction. Okay, now see here, I have taken equation of motion. V is equal to u plus at. Okay, it is for first electron I have taken 1 1 1. Acceleration will be the same. Okay, for second electron v2 u2 plus a t2. Okay, for second electron like this. Okay, for third electron you can write 3 3 3. Acceleration will be the same. Okay, so velocity for nth electron is going to be un plus a tn. Like that we can write. Okay, so first electron, second electron, third electron, we have n number of electron will be flowing from one end to another end. Okay, now we are going to take it as a average velocity. Okay, so we can add all the things, all the electrons together, we will get as the average. Okay, so v1 plus v2 plus dot 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 vn. Okay, it's the overall mean velocity divided by n is equal to u1 plus u2 plus dot 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 un divided by n plus acceleration t1 plus t2 plus t3 dot 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 tn divided by n. Okay, now we will be learning with what is the average velocity. Average velocity of all the electron we can write as drift velocity. Average initial velocity is not going to get anything. Okay, so initial velocity we can take it as average initial velocity, we can take it as a 0. Okay, acceleration, average time period we can take it as a relaxation time. Okay, average time taken, it's going to be the relaxation time. So I am taken like this: average velocity, average time period, average initial velocity will be 0. Okay, so now we can get Vd is equal to a tau. Okay, this what we have equation. Okay, now what is I am going to relate with the acceleration. How I am going to relate with the acceleration? Force is equal to ma. Force is equal to mass into acceleration. I am taken this equation to relate with the acceleration. See how I am going to relate. Electric field also I am going to relate. So right now we are learning vector form of Ohm's law. Okay. So F is equal to ma. Electric field is equal to force per unit charge. Here charge we are talking about the electron. So force is equal to, it is electron into electric field. Already we know force is equal to ma, mass into acceleration. Force is equal to mass into acceleration. Now if we want what is acceleration, this two equation you can take it. E is equal to ma. What is acceleration? Acceleration is equal to like this. A is equal to E divided by m. Like that we can take it. Okay. So now we got what is acceleration. Okay. So we have drift velocity. Okay. Drift velocity is equal to a times of torque. So now we got what is a? E divided by m into it's going to be the torque. Torque is going to be the relaxation time here. Okay. Now see what's going to happen. Electric field we can call potential gradient. Potential gradient is a volt per unit length. Like that also we can take it. Okay. So electric field is equal to force per unit charge, one of the formula. The another formula we can take it as a electric field is equal to volt per unit length. Like this also we can take it because this two will be equal. Okay. In another video I will make it this two as a equal. I will prove it. Okay. Now force per unit charge is equal to volt per unit length. Okay. This two will be equal. Okay. Now electric field we have. So drift velocity is equal to E. What is electric field? Electric field is equal to volt per unit length into m tau. Okay, like that we'll get. Okay, now I am going to relate with current. Okay, because we know already current equation I is equal to N E A V D. Okay, This what we know already, what is the current. Okay, now we found what is drift velocity. Just I am going to substitute. I is equal to N E A. VD is EV torque divided by M L. Okay, this is a main equation. Okay, this is a main equation. From here only, I am going to do it with all the solution. Okay, this is a main equation. Okay, so see here how I am going to do the problem. So I got like this. Okay, I'm going to bring the voltage here. I'm going to bring the voltage here. So I divided by A. If you are bringing voltage here, like that will be that. Okay, is equal to N E square A torque divided by M L. Like that we'll get. Okay, if you want to relate with the resistance, just flip the equation. I is equal to V by R. Okay, so otherwise R is equal to V divided by I. Just to flip the equation is going to relate with the resistance also. Okay, so I flip the equation. V divided by I is equal to M L divided by N E square A torque. Like that we'll get. Okay, now what is this V by I? According to Ohm's law, this is going to be the R. So resistance is equal to M L divided by N E square A torque. Like that we can have. Okay, now I am going to relate with resistivity also. Now I related with resistance, then I am going to relate with resistivity also. See here how I am relating with resistivity. So we know the factor affecting resistance directly proportional to length, inversely proportional to area. When we are moving directly proportional, we should include the constant, that is going to be resistivity length by area. Okay, so the same equation, R is equal to M L divided by A N E square A. Okay, this together we can take it as a resistivity. Okay, now we got what is resistivity. Resistivity is equal to M divided by N E square A. Just a comparison of these two equations. I'll get what is resistivity. Okay, now what is conductivity? Conductivity is inversely proportional to resistivity. So sigma is 1 divided by rho. Now 1 divided by M divided by N E square A. This if you are bringing as numerator, N E square A. A torque also will be there. Okay, A torque divided by M. This is the conductivity. So resistivity inversely proportional to the conductivity. Okay, now vector form of Ohm's law. How I am going to write with vector form of Ohm's law? We have the another question. How we are going to write vector form of Ohm's law? Already I told you the important equation. I divided by A is equal to N E square torque V divided by L divided by M. Okay, if you are bringing here V, it's going to relate with resistance. Okay, now current density is equal to current per unit area. Electric field is equal to volt per unit length. Simply we can call like this. Okay, so this everything we can call current density. This everything we can call as a electric field. Okay, now current density is equal to dash times of electric field. This much times of electric field. What it is? Okay, it is a conductivity. Already I wrote this is a conductivity. Conductivity we can write as a sigma. Okay, this is a vector form of Ohm's law. Okay, in case if you want resistivity equation, you can bring the conductivity here. E is equal to J1 divided by sigma. 1 divided by sigma we can call it is a rho. That's going to be the resistivity. Okay, so J times of resistivity is equal to electric field. So I got it's a vector form of Ohm's law. Okay, J is equal to sigma times of E and E is equal to rho times of J. Okay, so now we learned what is a vector form of Ohm's law also. Okay. So from this we got the resistivity equation, conductivity equation, relation between current and drift velocity, okay, and the relation of current density and electric field. So these are the concept we learned. Okay, it's a very lengthy concept and also it's a very important concept where we are going to use this all the formulas. Any of the formulas they can relate with some concept they will be asking the numericals. Okay. Now I am going to move with the next thing. It's going to be called as the color code. Okay, identification of color code. So now we are going to find identification of color code. Okay, resistance color code we are taken. Okay, resistance color code usually will be taken as a color code B. First color is a black, BB. Second one is a brown, BB Roy, great, Britain, very good, wife. Like that you can write. Okay, so it is a color code of the resistance. Okay, first black, then brown. Okay, this is a blue because 3 B's we have, that you need to know. Okay, so this is 0. It is 1, it is 2, it is 3, 4, 5, 6, 7, 8, 9. Like that we have. Okay. Then we have the tolerance. I'll explain why what we are going to use this color code. Okay. Tolerance. Okay. First is the gold. Next one is the silver. Third one is the no color. Okay. No identification. No color. Okay. So it's going to be the 5% error. Okay, in case gold color you got means 5% error will be there. Okay, then in case if you got silver means silver color means 10% error will be there. If there is no color is there means we will get the error of 20% error will be there. Okay, now I am going to do with the resistance. Say if example we have the resistance. Okay, like this we have the resistor. Okay, we got different color. Okay, so I'll give it is a yellow, violet, orange. Okay, then here it is a gold color. In example like this they will give the color code. Okay, so it's one of the questions they asked in NEET also. Okay, so now how I am going to convert with this as a resistance. Yellow is how much? Yellow is 4. Violet is how much? Violet is 7. Okay, and orange is how much? See here, orange is 3. Okay, so third color always you should write in the power of power value. Okay, 10 power something. Okay, first color direct number, second color direct number, but the third color always you should write the power of 10 power something. Okay, then we have the gold. Gold is plus or minus error. Okay, so in this problem we have the 5% of error. That's an indication of gold. Okay, now we have 47 kilo ohms also we can give this answer, plus or minus 5% error, that you can give like this. Okay, now we'll do with the reverse order. We have 58 into 10 power 7 plus or minus 20% is the error. Okay, like this is given. So now how you can find the color code? Okay, for 5, what is the color? 5 is green. Okay, so green color. 8, what is 8? Wait, green, gray. Okay, so 8 is gray. Then it is a third color, it's a 7. Okay, 7 is a violet. Okay, green, gray, violet. Then error is 20%. There is no color for error. Okay, I'll repeat again. Okay, so we got some number, x number. We'll take it 2 into 10 power 2. We'll take it like this. This much ohm plus or minus 10% error is there. Now what is the color code for this? Okay, for 2, red color. Again 2, red color. Okay, the power of 2, red color. So red, 3 red will be there. Okay, then error will be there. How much error? 10%. 10% means it's a silver color. So plus or minus silver color will be given. Okay, so both the way we need to know how to convert from color code to the resistance and resistance to the color code. Both the way you need to know how to convert. Okay, now we learned how to do with the color code. Okay. Next we are going to do how the factors will get affected, how the temperature will get affected the resistance. Okay. Now we are going to learn how the temperature is going to affect the resistance. Okay, I have the wire. Okay, I have the wire. 0 degrees Celsius, it's 27 ohms. Okay. We'll take it 50 degrees Celsius, it is 80 ohms. Okay. When the temperature is increased, the resistance will be increasing. That's the concept we need to know. Okay. So resistance directly going to affect with the temperature is directly going to affect with the resistance. Okay. When the temperature increases, resistance also will be increasing. Okay. So temperature versus resistance. I'm going to give one specific equation. RT is equal to R naught 1 plus alpha t. We don't have special derivation for this. Okay. We don't have any derivation for this, direct formula only. What is RT? According to this, RT is 80 ohms. Okay. Because 50 degrees Celsius, the resistance will be 80 ohms. Okay. So RT will be the resistance at particular temperature. What is R naught? Okay. Resistance at 0 degrees Celsius. What is resistance at 0 degrees Celsius? It's going to be 27 ohms. Resistance at 0 degrees Celsius, it's going to be the 27 ohms. What is T? Okay, actually here we can write RT is equal to R naught 1 plus alpha del T only usually will be writing. What is del T now? Final temperature minus initial temperature. Okay, for this case when they related with 0 degrees Celsius, RT is equal to R naught 1 plus alpha T2 minus T1. Like that we can write. Here T1 is 0, T2 will be the T. Okay, so it increases from 0 to something. So when you are taken here is the R naught, this is going to be the 0. So that finally you will get as a T temperature. Okay, I hope you understand. Okay, now we'll be doing with next equation, another equation. Okay, so R2 is equal to R1 1 plus alpha T, alpha del T. Okay, alpha del T. Del T is going to be represented as the change in temperature. The same equation you can write R2 is equal to R1 1 plus alpha T2 minus T1. Like that we can write. Okay. When we can use this equation? When we can use this equation? When you are using this equation, they have to relate with 0 degrees Celsius. Okay. Directly you can use this equation. But if they are not related with 0 degrees Celsius means you can use this equation. Okay. This equation indicates, okay, initially resistance at particular temperature, finally the resistance at particular temperature. Okay. So example, initially they won't relate with the 0 degrees Celsius. Okay, 100 degrees Celsius, 80 ohms. Okay, 200 degrees Celsius, 100 ohms. Okay, see here T1 is 100, T2 is 200. Okay, and here R1 is 80, R2 is 100. Okay, like that we can relate with this formula also. Okay. Now what is alpha? Alpha is a temperature coefficient. Okay, if the 1 ohms it's increase means the same thing 1 degree Celsius also will be increased. Okay, alpha is the temperature coefficient which is indicate the how much how much temperature will get rise. So per degree Celsius how much resistance will be increasing, that is called alpha. If you want alpha formula you have to modify this equation. That also I am going to do it now. Okay, alpha is how much resistance will be changing with per degree Celsius. Okay, R2 is equal to R1 1 plus alpha T2 minus T1. We are going to find what is alpha. Alpha is temperature coefficient which is a constant for material. Okay, we have the tabular column also for this. Okay, so this R1 I have taken this side, R2 minus R1 is equal to so this R1 first I am taken inside R1 plus alpha R1 T2 minus T1. If you want what is alpha, this you can take it this side, R2 minus R1 is equal to alpha R1 T2 minus T1. Okay, if you want what is alpha, this you can bring as a denominator. Okay, so finally you will get what is alpha. So alpha is equal to R2 minus R1. If you are bringing this as a denominator, R1 T2 minus T1. Like that we will get. This is going to be the temperature coefficient. What is the unit of this? This is ohms. This together will be ohms. This will be ohms. Okay, and this will be degree Celsius. Okay, ohms get cancelled. The unit of this is going to be per degree Celsius. Okay. So today we learned current electricity 3 concepts. One is a color code. The another one is how the factors will get affected, the resistance and also vector form of Ohm's law. These are the three concepts we learned. Okay. Thank you. Bye bye. Tomorrow we'll be having the chapter current electricity part 4. Okay, actually in this series we are going to do every day 9 a.m. we are going to do with the current electricity continuation. Okay, so already 3 parts over. Okay, I'm going to do with each and everything from the current electricity. Today we are doing with the part 3. Okay, tomorrow we are going to do with the part 4. Okay, bye bye.